So this problem is related to concept of potential and electric field. So what is the relationship between electric field and potential you have? So let us copy this one. This is a quite easy problem. You can do yourself. Okay, let me read the language. So this says, find the electric field strength vector if the potential of this field has a form of A dot R. So potential is given by this function A dot R. We have to find electric field for this field. Now we have to give, and also there is a constant vector A. A is a constant vector, so this is A, that is a constant vector, this is dot product. And we also have R is the radius vector of the point of the field, so R is the radius vector. So how will you proceed? So basically in this problem you can use the fact that is potential is electric field is differential of potential. I can use this form. Ex is nothing but minus del V over del x, and Ey is nothing but, so let us write here E by, not minus E by, I can write in the bottom also. So Ey is nothing but minus del B over del by. Similarly Ez is nothing but minus del B over del Z. So if you use this relation, you can find the answer. Now see, potential is given as A dot R. Now you can take A as a vector AXI plus, so let us take vector A as AXI plus A by Z plus AZK. Are you getting? Similarly, R can be treated as XI plus by Z plus ZK. Now A dot R can be written as X into AX into X, because I dot I is 1 plus I dot Z is 0, I dot K is 0, so I have to take this term only, A by into by plus AZ into Z. Are you getting? So this is the value of A dot R. Now I have to differentiate. So if I want to find Ex, I will use minus del V over del X is equals to Ex. So let us say, if I simply write minus dV over dx, because I have to treat by and z constant. So if I differentiate this, by and z constant, so differentiation of this is 0, differentiation of this is 0. Now differentiation of this term, so differentiation of x will be 1 and ax is a constant, so this will be simply minus ax. You can verify yourself. Similarly, you must know all these results. E by will be minus dv over d by, and I can write this is nothing but minus a by. Similarly, Ez, this will be minus dv by dz, and it will be minus a z. Are you getting or not? So copy this one. Now resultant electric field can always be written as in this way. So E is written as EXI plus E by Z plus EZK. So electric field resultant can always be written in this form. So this is EX is what? EX is minus AX. So this is minus AXI cap plus this is EY is minus AY. So this is minus A by J cap plus minus AZ K cap. Are you getting? So you will have this value. So if you take minus common, you will have axi plus a by j plus azk, that is vector A. Now this means electric field is simply given as minus A. So electric field is basically a constant, vector A is a constant, so electric field is constant, not only magnitude wise, it is also constant direction wise, because direction of A is constant, so electric field is basically constant. So this problem only relates a small concept, that is electric field can be given as gradient of potential, and if you know the gradient, that is the differential, you have to treat that y and z as constant, so there is a partial differentiation. So Ex you can get dv by dx treating y and z constant, Ey you can get dv by dy keeping x and z constant, you can get Ez keeping x and y constant, dv over dz will give you Ez. So now if I know Ax, Ey, Ez, I can always superimpose these three components into Exi plus Eyj plus Ezk to get the total electric field. We'll discuss the next problem. I think all of you have copied this one. So this is a pretty easy problem. This is the easiest problem till now we have done.